Hello everyone, my name is Anish Rana and you are watching Kubernetes web series. In this video, I will try to explain DNS functionality on Kubernetes cluster. Today our agendas are why we use DNS in Kubernetes. In this topic, I will explain you how to locate DNS ports and some basic information. And next, we will learn how DNS entries are made for ports and services and how to use config file, how to log in DNS ports, and in the end, we will follow the lab. So let's proceed for our first topic, that is why we use DNS in Kubernetes. Although there are many reasons to use DNS services in Kubernetes, let's elaborate the main points. First is in Kubernetes environment would have hundreds or potentially even thousands of objects with unique IPs. Keeping track of IP address of all of them by hand is not possible. On the top of that, in Kubernetes, pods are ephemeral by its nature. It means whenever pod dies, it will be created by deployment again, and the created pod will get the new IP address probably. Thus, it would be good to have one name, and behind this name, IP should be attached. Third main point would be by translating the service name into IP address will resolve many issues such as keeping track of changes of pod IP address automatically. DNS services in Kubernetes make it life much simpler for admin. So when we create a services, our Kubernetes will assign one IP address, whether it's a load balancer, node port, whatever, right? We can access those services by its name, and the IP address is now transferring to the endpoints. It means that we just need to remember the name of services. It make our life very easy, right? Now I hope you understand why we use DNS service in Kubernetes. Now our second topic is basic information of DNS Kubernetes. This is our Kubernetes cluster. DNS is a built-in Kubernetes services launched automatically using the add-on manager. Before Kubernetes version 1.11, the Kubernetes DNS services were used or based on kube-dns. Version 1.11 introduced CoreDNS, an open source DNS server written in Go language to provide DNS across the environment. It is designed specifically for cloud native environments. Now, I hope you understand the difference between kube-dns and core DNS. Let's go ahead with some theoretical points. DNS is a built-in Kubernetes services launched automatically using the add-on manager. This is what we learned. It means that you don't need to install or configure the DNS service like we do for Calico networking. These are the bullet points that you can use in future. Before Kubernetes version 1.11, the Kubernetes DNS services was based on kubedns. Version 1.11 introduced core DNS to address some security and stability concern with kubedns. Kubernetes create DNS record for services and pods automatically. That is what we discussed earlier. Kubelet configure pod DNS entry so that running container can look up services by name rather than IP address. DNS query may be expanded using pod etc resolv.conf file. Kubelet configure this file on each pod. It just says that if you want to use your own DNS server, you can just add the entry inside this etc resolv.conf file. I will explore this option in my coming slide. Don't worry. Kubernetes DNS add-on currently supported forward lookup, a record, port lookup, SRV, reverse lookup, that is PTR record, and some other options. CoreDNS is deployed in a simple way. It runs as a cluster level pod and handle DNS queries within the cluster from there. It's very simple. By default, the services is named kube-dns. One or more ports are created. If we execute this command kubectl get service minus n kube system, you will observe the cluster IP address with the name of kube-dns. This is what I have written here. By default, the service is named kube-dns and one or more port will be created when you create the Kubernetes cluster. From this command, you will get to know that all my DNS ports will be created inside the kube-system namespace. Let's elaborate more. If I execute this command kubectl -nq-system get port, I will observe two ports. Now you can see that CoreDNS ports are running or working on my master nodes. If I execute this command kubectl get all -n cube-system -o void and grep core, what I am doing here that I will list all the things which are named core. From this output, I get to know that when we install the Kubernetes cluster, one deployment that is core DNS will be created, and this deployment will create a replica set with the name of core DNS and some numbers. This replica set will create two pods. I have already uploaded one videos for deployment and replica set. If you have not cleared the funda, then you can clear it after watching that video. But as of now, you can just think about that. Deployment will create a replica set and replica set will create and manage the pods, whatever mentioned in the deployment replicas. So in this scenario, in this case, this deployment YAML file, the replica is 2. So replica set will create or manage two pods. Okay, let's go further. So this is my deployment and this is my replica set and this replica set will manage two pods. Fair enough. If we check the service inside kube-system namespace, we will observe one kube DNS services also there. This is what we explored in the previous slide. It means that we can use this IP address to resolve the DNS query. If we describe the service kube-dns, we will get to know that this service will pointing out to the endpoint is here 41 and 42 IP address, right? And these are 41 and 42 IP address is this one. Fair enough. If we access this IP address, it will point to these two ports. Okay, I hope it is clear now. Let's move forward. If we check the config map inside the kube config namespace, we will observe core-dns config map. Here it is. This is my get config map. CoreDNS config file is saved as a form of config map. In short, we can say that this config map is bind with the deployment. In future, if any CoreDNS pod goes down, then replica set will create a new pod and attach this config map. We will not lose the DNS configuration when pod recreated. Let's explore this config map. What is this? Now, if I execute this command kubectl -n kube system get config map and then config map name that is CoreDNS -o YAML. These are the plugins it uses. You will find more information on Kubernetes website directly. I have added the link in the description of this video, don't worry. File name is core file. Port number it uses is 53. This is the default port number of DNS. Error, print error to standard output std out. Health, generate health check report for core DNS. The default listening port is 8080. This plugin is used to evaluate the health status of CoreDNS. Let me show you how we can check. First, identify the core DNS port IP address. Then use curl command with port IP and followed by 8080. If you observe output is okay, then it means that your DNS service is working fine, absolutely fine. Let's move back to our config map plugins. Detail value is 30. Forward DNS query to preferred DNS server in etc resolv.conf file in the host node. Let's suppose if you type ping google.com and google.com is able to resolve this pod IP or cluster IP, then it will forward the request to your node etc resolv.conf file, and from there it may get the answer of google.com. It maintains the DNS caching table. Of course, you will find more information in Kubernetes website. If you want, you can explore it. It would be worth if you can go to this website. Let's move forward. Advanced level of DNS Kubernetes. The kube-dns services listen for services and endpoint events from the Kubernetes API and update its DNS record as needed. These events are triggered when you create, update, or delete Kubernetes services and their associated pod. A pod would have a record in the format of pod IP dot namespace dot pod dot cluster dot local. If you can think about it, there is a last dot here. So 1 dot, 2 dot, 3 dot, 4 dot, and 5 dot. A service would have a record in the format of service IP dot namespace dot svc. Now here it is svc and here it is pod and cluster dot local. Let's create the namespace, pod, and service inside the core namespace so that I can show you the DNS records. Here I created a core namespace. After that I created a deployment and it has 3 replicas. Further, I exposed this deployment through node port service. In the end, I checked the IP address of all objects inside the core namespace. This section is also covering the lab part. This is my namespace core, and here I'm going to create a deployment inside this core namespace, and replica is 3, and here I'm exposing the deployment, and the name of this deployment is frontend and blah blah blah. I have already covered, so I'm not going to elaborate this thing. Now if I use kubectl minus n core get all and minus o void, I will observe the IP address on which worker node it is created. These ports are created here, right? These are the 3 ports, right? My pod IPs are these. My core DNS port IPs are these. If I try to resolve the port name, however, my DNS service is running on this IP address. This is my cluster IP for kube-dns. If I try to resolve the port name by using DNS service cluster IP, I will get no answer because the format is not good. If I try to resolve the port IP by using DNS service cluster IP, I will notice my service IP address. It means that reverse lookup will resolve the port IP plus name of service which is exposed for this port. You see the beauty of Kubernetes. 133.166 is my pod IP, right? And after that, it mentioned the front-end service. This is my service name. And then namespace service.cluster.local. This is the name it resolved. But this IP address is belong to pod. However, for the forward lookup, if I use the correct format, that is IP is separated by hyphen instead of dot followed by namespace, then pod, and then at the last cluster.local, I will get the desired output. This is my pod IP address. For port forward lookup, a record is like this: IP address of the port separated by hyphen instead of dot, and the format that I described in the previous section. Let's explore the service one. There is a small difference. Let's check the service IP address what we created inside the core namespace. This is my cluster IP. If I try to resolve the IP address, this time I will observe the name service only. This is the name and this is the IP address. If I try to resolve, and please bear in mind whenever we are resolving the PTI record, we have to use -x option. This is my IP address and it resolved the name of the service and then core service name. And if I'm trying to resolve the name front end service core SVC, I will get the IP address of the service. However, for the pod, it is different. Let me show you again here. For the pod, I have to use IP address instead of name. Okay, let's move forward. Now let's go inside the pod and verify all these steps what we performed in the previous slide. Here I'm logging inside this first pod. In order to resolve the name, I need ns lookup command. For that reason, I'm just installing these packages iputils, ping and DNS util. After that, I can use dig command and this is the IP address and the format is core.pod. I can get the IP address. Same as it is for forward lookup a record, and a record it should be like this, and I can resolve the name. It means that we can resolve the pod or service records from the master node or inside the pod as well. And this is for PTI record. And this is for service. So pod, this is my second pod. It is all I can also able to resolve. And service is also resolving PTI record. This time I created a pod in the default namespace and try to resolve the pod which is running under the core namespace, and I can get the answer. What we learned from this is that DNS functionality you can use at any place. To elaborate this, you can resolve any port's name on any namespace inside this cluster. I hope it is clear now. In the advanced section, you have to remember the format of pod name. How can use the name of the pod. Let's log in into the pod, one pod. Check the etc resolv.conf file. This config is used by DNS clients to forward the DNS query to the name server, DNS server. Resolv.conf file is the resolver configuration file which has information for search. This option represents the search path for a particular domain. Interestingly, google.com or example.com are not the FQDN. FQDN means fully qualified domain name. In domain name, if we add dot at the end, then only it is called FQDN. Thus, we can say that example.com is not a FQDN, but example.com dot is the FQDN. The second option is name server, where the DNS queries are forwarded to. In our case, this is the core DNS service IP address. And the last option is option ndots. Ndots represent the threshold value of the number of dots in a query name to be considered as a fully qualified domain name. By default, it is 5, but you can go till 15. Let's explore more with the help of some example. If we try to resolve Kubernetes only, and this is not a FQDN, thus it will try to search the entry from these options. One can observe that there are two answers from each search option. For an example, svc.cluster.local, you will observe two times here. The reason behind is that whenever we try to resolve any host name, it will look up for IPv4 and IPv6. For IPv4, it is look up for A record, and for IPv6, it is look up for AA. It means 4 times A. If we use dot at the end with the same name, then our resolver will send the traffic directly to the root server and try to find the answer. However, in our case, there is no domain with .kubernetes exists on the internet. That's the reason we are getting no server could be reached. I hope you now understand the meaning of ndot in Kubernetes. In short, we can say that whenever we try to resolve any host name, it will search these things, these parameters. If it's not found, then it will forward the query to name server. And how it define whether it's a fully qualified domain name or not, if we add at the end or if we use ndots. In the previous example, as you can observe that there is 5 dot here. Dot at the end, 1, 2, 3, 4 and 5. So it consider this host name as a fully qualified domain name. Our next topic is how to log in into DNS pod. First, we need to identify the IP address of our DNS pod, and if we execute this command, we will get to know the IP address of our DNS pods. Now, in order to log in into DNS pods, first we need to find the container name, and then we can use debug command instead of exec. And in the end, we need to add -- target equal to CoreDNS. Once you use this command and press enter, you will able to log in into the DNS pod. But if we use our traditional way to use exec command here, you will not able to log in inside this DNS pod. After that, you can identify if it's a right pod or not. You can execute IP space A show ETH0. You will observe the same IP address what we have mentioned here. This is the way. Now let's proceed for our last topic, that is lab. Lab is already prepared. For this reason, I just click on repository and click on Kubernetes. If I scroll down, I will observe kube-dns. Click here, and the topic of the lab would be how to find the DNS port name in cluster. All these commands I have already explained in my PPT. If you want to see the lab, yes, you are most welcome. How to see the ports inside kube system. It's a very simple command. All these are the ports that are created by default when we create the Kubernetes cluster. And if we want to see the services, what are the services it is created by default when we create the Kubernetes cluster, kube-dns service is created. If you want to describe this service, let me clear the window here. As you can see here that these are pointing to one IP address and colon 53. 53 is the port number of DNS server. If you observe 68.55 and 68.56, Both are my core DNS IP address. I will show you in a couple of minutes. Don't worry. If I copy here, yeah, this is the 68.56 and 68.55. Okay, let me clear the window. Now move forward. DNS deployment configuration file. Now we know that this DNS server is created with the help of pod, but how we can check the configuration of this pod? The configuration is set inside the config map. Inside this config map, you will observe CoreDNS config map is already created here. And if you want to elaborate more, what are the content inside this config map, you can use YAML. Oh, YAML, output YAML, as I described in my theory part. Port number 53, error message generate, health check, how we can check the health check that I have already covered. Cache is 30, loop, reload, if pod is down then it will reload the services, load balancer, one service goes to first port, second request will go to second port, like this. And how you can check? So this is the command curl http kube-dns IP pod IP address. How we can check the IP address? Let me clear the window. These are the IP addresses, and instead of this I just made one command here. If I execute this command, I will observe the IP address of one of the port, the first port, that is 68.56. If I use the same command and put it here http, then I will get the OK result. If I receive the OK result, it means my DNS is working fine. And this is the case. Let's go to our third topic, that is how ports and services are resolving the Kubernetes clusters. For this, let's create a lab. First, we are going to create a namespace and then we'll create the deployment and then we'll expose this deployment with one service is front-end SVC services and type is node port. Let's create one by one deployment and then expose this deployment with one service. Remove everything. If we use -n core and get all with -o void, I will observe all the IP addresses is assigned. What are the IP address it is assigned? We will get to know. Okay, so let's move forward. And if I use CoreDNS, I will observe my DNS IP address. And this is my service IP, cluster IP, right? By default, this one. If you use this IP address, it will forward the request to DNS ports that I showed you earlier here, both. Let's try to resolve the deployment port names. For this, I need to copy here and port what it says front-end port name. And this is my front-end port name. It should not resolve because the format is not good. Let's try to resolve the port IP address here. And this is my IP address of my pod. If I right click, I will get the answer. This is the correct format. If I go up, Control W and then hit enter, I will observe the IP address of the pod. It means that this is the correct format, and one can notice that when we try to resolve the IP address of pod, I will observe that my service name is here. This is the reason I showed you here. This is my service, right? And this is what it is resolving here. After that, namespace service.cluster.local. This is what we have already done. kubectl -o get services. This is my service IP. Okay, so let's resolve this service IP. Will it work or not? Let's see. It should work ideally. and here you will observe the service name. But for pod, it is the IP address, pod IP address. Instead of dot, it is hyphen and then service name. But when we try to resolve the IP address of service, I will observe the name of the service. And if I try to resolve the name, and the name is same. For pod, there is a format, but service, it is like this. Resolving the pod and services from inside the pod. Same exercise, we need to do it again. First, we get to know the IP address of pods, and then we need to log in into one pod. Instead of this command, I can also use like this exec minus it and pod name. Instead of this, if you want to use this command, you can use this command. What I did here, I just print the first line of this pod. Whatever the pod, it is printing on the first line. So I just use this one. If I use this command, it is also take you inside. Pod IP address, and it should be hyphen instead of dot. Okay. It says dig is not here. So I have already forget this update and install iputil command. Actually, I did it intentionally so that you can also get to know that if you not install these packages, dig command will not found. Here I say exit from the pod and execute blue command again. Once it's done, I exit and IP address of my pods, go inside again here and use this one. Now I will observe that dig command is working fine because I installed the packages and it is also resolving the IP address. Let me show you one thing more here. You can also resolve the second pod IP without any issue. Let me show you. It means that DNS is working globally at cluster level, not at pod level. Same thing I have mentioned here, pod 2 IP address, pod 1 IP address, and if I try to resolve the IP address, let me use the third one. It is also resolving it. And if I want to resolve this host name, I can also use this one. Okay, I have to remove minus x. Minus x is for IP address. Service IP cluster. If you want to resolve the service IP cluster is also resolving. Let me show you here. This is my service IP. Let me resolve this. It is also resolving. In short, we can say that DNS functionality is working at global level and resolving the record from the namespace for other port name. Yes, you can also resolve. Let me show you. I just created one pod here. Let's go inside this pod, and after that ns lookup pod IP of core port name. Okay, whatever, I can use this one. Okay, here it is also resolving. It means that whether you are in one namespace or other namespace, if you know the IP address or correct name, you can resolve it thanks to DNS. And in the end, if we cat resolv.conf, here these are the service. And if ns lookup Kubernetes, it will go to all default example.com cluster service, everything it will go, and default it is here. The Kubernetes default service is already there, so this is the reason it is resolved. But for other, it never go. And ndot is 5. I have already explained, and the name server is 0.10. This is the name server. Whenever this cluster receive any DNS request, it will forward the request to this name server and it will find from these zones. These are the zones file. Example.com cluster.local, svc.cluster.local and default.svc.cluster.local. Let me log out from here, this part. How to log in? Let's check the core. This is my port IP. Let me show you here. kubectl minus n kube hyphen system exec minus it hyphen bin bash. It will give me the error message. How to resolve this issue? You just need to first you need to check the container name of this pod. How you can identify it? This is the command minus output JSON path. Range is item and inside this specs dot container and inside this container we have name section. It will print the container name and after that I can use debug option instead of exec my pod name and then hyphen image bgbox 1.28 and target equal to CoreDNS. This is my container name. If I click here, you will observe that you are inside this DNS pod. You can also check the IP address of this pod is 68.56 and 68.56. This is the IP address. It means that you are landed on the correct pod. Control D, exit, and how to clear the lab. Clear the window. I hope this is the interesting topic and you like this topic very much. If this is the case, please like and comment and share this video with your friends and colleagues. Thank you very much. Bye bye.